intermolecular forces. Whether a particular group of bonded molecules takes the form of a solid, liquid, or gas depends not only on the bonds that exist within each individual molecule, but also on the presence and type of bonds between molecules. Hark back to the different types of bonds we reviewed in the last chapter. Ionic, covalent, and metallic. Of these, ionic bonds tend to be the strongest, and this means that substances that contain ionic bonds are solids at room temperature. Substances that are primarily made up of covalent bonds, which are weaker, can be solid or liquid, and their state will depend on the presence and type of intermolecular forces. The two main types of intermolecular forces that exist between molecules are dipole-dipole forces, including hydrogen bonds, and London dispersion forces. Dispersion forces or London forces. London forces are relatively weak forces of attraction that exist between nonpolar molecules. These types of attractive forces are caused by a phenomenon known as instantaneous dipole formation. In this process, electron distribution in the individual molecules suddenly becomes asymmetrical, and the newly formed dipoles are now attracted to one another. That larger nonpolar molecules tend to have stronger London dispersion forces. This is evident when you look at the diatomic elements in group 7, the halogens. All of these diatomic elements are nonpolar, covalently bonded molecules. Now, going down the group, fluorine and chlorine are gases. Bromine is a liquid, and iodine is a solid. For nonpolar molecules, the farther you go down the group, the stronger the London dispersion forces. Dipole-dipole forces. Dipole-dipole attractions take place when two or more neutral polar molecules are oriented such that their positive plus and negative minus ends are close to each other. Because of the attraction between unlike charges, this is a fairly strong type of intermolecular force, and molecules held together by dipole-dipole forces tend to be in the solid or liquid state. Also, for molecules that are about the same size and weight, the strength of the dipole-dipole forces increases as the degree of polarity increases. In other words, the more polar a molecule is, the stronger the dipole-dipole forces it will form with itself and other molecules. One very important and unique case of the dipole-dipole attraction is known as hydrogen bonding. Hydrogen bonds are not true bonds. They are just strong attractive forces between the hydrogen on one molecule and a highly electronegative atom on a nearby molecule. Hydrogen bonds most commonly form between hydrogen atoms, oxygen, and fluorine or nitrogen. This type of intermolecular force is responsible for water's unique characteristics, such as its high specific heat and boiling point temperature. Dipole-induced dipole forces. This type of attractive forces operates between the polar molecules having permanent dipole and the molecules lacking permanent dipole. Permanent dipole of the polar molecule induces dipole on the electrically neutral molecule by deforming its electronic cloud. Thus, an induced dipole is developed in the other molecule. In this case also, interaction energy is proportional to 1 by R6, where R is the distance between two molecules. Induced dipole moment depends upon the dipole moment present in the permanent dipole and the polarizability of the electrically neutral molecule.